Okay, welcome to our next lesson in our unit on circles. Okay, today we're going to be talking about the difference between radians and degrees. So first off, what is a radian? You are used to expressing the measure of an angle in degrees. There's another unit of measure for angles that we call radians. A radian is defined in this way: a central angle of a circle that measures 1 radian marks off an arc length that is equal to the radius. All right, so now we get here to the bold underlined statement here. It says, how many degrees is 1 radian? So what's the conversion factor here? To determine this, it says find the measure of an angle in degrees that creates an arc length that is the same as the radius of the circle. Express your answer both in terms of pi and as a decimal. All right, so in our previous lesson, we learned that the equation for arc length equals the degree of the central angle divided by 360 times the circumference. The circumference is 2 pi r. All right, so in this case, in the circle that they've given us over here on the left, they tell me that the arc length is 1 inch. So for arc length over here, we're going to substitute in 1. For our degree measure, they've used the Greek letter theta. Okay, we're used to usually using x or y or z or something like that. They just use theta instead, no problem. Okay, so theta looks like that, divided by 360. All right, and then times 2 pi r. Well, our radius, they tell us in the picture, is 1 inch. So we can substitute a 1 right in here for r. All right, when we clean this up a little bit, we notice that we have 1 equals, I'm going to write over the drawing here, theta over 360 times, really just 2 pi, because anything times 1 is just itself, so we just have 2 pi right here, right? So our next step in solving this would be to divide both sides by 2 pi. Since we're multiplying it over there on the right, I'm going to divide that whole side by 2 pi. I'm going to divide the 1 over here by 2 pi as well. Okay, our goal here is to get theta by itself. So the 2 pi's on this side both cancel out. So I'm left with, I'm going to come over here to the left. I'm left with 1 over 2 pi equals theta over 360. Okay, from here I would cross multiply to figure out the answer to my equation here. So if I cross multiply these fractions, I get 2 pi theta, and then 360 times 1 is just 360. And then to solve for theta, I would divide both sides by 2 pi. The 2 pi's would cancel out on the left, so I'm left with theta equals 360 divided by 2 pi. Now I could simplify this because 360 divided by 2 is just 180. So really theta is going to equal, in terms of pi, it would equal 180 over pi. Alright, if I punch that in a calculator to actually get the decimal version of this, I would get 57.3. So theta equals 57.3. All right, so the question in bold underlined in the middle, it says how many radians is 1 revolution? So 1 revolution means you're going around the whole circle. We know that the circumference of a circle is equal to 2 pi r. All right, well in our picture above we said that the radius was 1, so if the circumference equals 2 pi times 1, then the circumference would just be 2 pi. So what we've done here now is we've shown you how to convert from radians to degrees. All right, so you see the two equations there in the middle. It says radians equals degrees times 2 pi over 360, or if you reduce that fraction, you could say radians equals degrees times pi over 180. All right, so we've got this box down here at the bottom. Let's fill in these blanks down here. It says 1 revolution, we just figured that out a second ago, is 2 pi. That's in terms of radians, or we know that 1 time around the circle is 360 degrees. All right, once again, if we reduce that fraction like we said just a minute ago, or you could say that pi radians is equal to 180 degrees. All right, so now we're going to go to the next page of our notes here, and we're going to start talking about how do we convert between degrees and radians. So if they give us something in degrees, can we change it to radians? If they give us something in radians, can we convert it to degrees? Up here at the top, I've given the two equations and the two ways that you can convert these. So depending on what they give you, you can go back and forth between the two. All right, so in our first example here, for instance, it says that the degree is going to be 90 degrees. Okay, well over here in our picture on the left, we know that that 90-degree angle would look something like that. Okay, we could put a little box right here in the corner to show that that's a 90-degree angle. So if I wanted to convert this from degrees to radians, I would use the equation on the right. Radians equals degrees times pi over 180. So my degree is 90, so I know that I just need to multiply that 90 by pi over 180. All right, when I do that, 90 times pi is 90 pi. And I'd still have my 180 on the bottom. And then I can just simply reduce that fraction. 90 over 180, if I reduce that, that reduces to 1/2. So I would just have pi over 2 as my final answer. All right, on my second question here, it says that my radians is pi. Well, we said, if you look back to the first page of our notes, we said that that means that pi is equal to 180. Now I'm going to show you why here. So we're talking about this right here. On the left, that picture there, that's going to be 180. Okay, now, but let's show you how we got that if we use the conversion here. Okay, degrees equals radians times 180 over pi. So now I'm using the equation that's over there on the left. So I'm going to kind of work from right to left here, which I don't usually do, but you'll be able to see what I'm doing here as we go from right to left. So I'm going to multiply this pi by, this pi by 180 over pi. All right, when I do that, I'll get 180 pi over pi. Well, those pi's just simply cancel each other out right there, so I'm just left with 180 degrees. All right, let's do the next one, 270. All right, so 270, if we're really drawing in our equation here, would be going all the way around this to right there. Okay, that's the angle that we're looking at. Okay, so this is a 270-degree angle right here. All right, so go back to how we did the first one when we converted 90, right? We multiplied by pi over 180. Okay, when we do that, we get 270 pi over 180. Okay, once again, this is a fraction that we can reduce right now. When we reduce 270 divided by 180, you can reduce that to 3/2. So this would be 3 pi over 2. All right, our next one is 2 pi. We're converting that from radians to degrees. So once again, I'm going to multiply this one by 180 over pi. All right, when I do that, 2 pi times 180 would be 360 pi. Over pi. Well, once again, those pi's cancel each other out right there, so I'm just left with 360. Okay, so we know that 360 is one time all the way around this circle. Okay, so 2 pi and 360 are the same thing. All right, on our next one, 30 degrees. All right, we know that a 30-degree angle probably looks something like that right there. So we want to figure out how much is this one in terms of radians. All right, when we do that, we're going to multiply once again by pi over 180. When we do that, we get 30 pi on top, 180 on bottom. We want to reduce this fraction if we can, which in this case we can. This is going to be pi over 6. Okay, you can always use your calculator on that. If you want, just divide 30 by 180 and then go to the reduced fraction, hit math, figure out what the fraction would be. All right, our next one is pi over 4. All right, so pi over 4, we want to convert that. So once again, working from right to left here, I would multiply this one by 180 over pi. Okay, when you multiply fractions, multiply straight across. So 180 pi on top. On the bottom, we would have 4 pi. Of course, once again, the pi's cancel out. Okay, what's 180 divided by 4? Punch that in your calculator, you will get 45 degrees. Okay, so 45 we know looks about like so. All right, for 60 degrees, we know what a 60-degree angle looks like, something probably about like that. Okay, let's convert this to radians. So once again, going from degrees to radians, we multiply by pi over 180. Use those equations at the top of the notes page here if you get stuck. 60 times pi, 60 pi. Still have 180 on bottom. Reduce the fraction, you'll get pi over 3. All right, one more to go here. We're going to convert 2 pi over 3 from radians to degrees, so we're going to multiply by 180 over pi. Okay, multiply straight across the top. 2 pi times 180 is 360. On the bottom, pi times 3 is 3 pi.